So this is a continuation of the recording introduction to graphing or calculus in the polar coordinate system. This one's slightly different than the first example. The first example just find the area enclosed by one graph. In this case, we're finding the area between two graphs. So between r equals 3 sine theta and r equals 1 plus sine theta. So in this case, I've already graphed it for you. If you threw this in your graphing calculator, you could also see this. And so the idea between the two graphs would be this little shaded in blue area. So if we're trying to find that area, notice it's a combination of these two graphs. Now in the xy coordinate system, or in the rectangular coordinate system, it's a little bit easier because we would just find the two graphs and we'd subtract one for the other for the height of the triangle, or height of the rectangle, and it wasn't that much more difficult. In this case, it's a little bit harder because remember we're doing sectors. So what I'm going to do is I'm going to divide this thing up into sectors. And you can tell by the way I'm drawing this, the sectors that I want are completely, so far, determined by the heart-shaped one, or the upside-down heart-shaped thing. Okay? And by the way, this is the circular thing, and this is the heart-shaped thing. Again, you'd be able to tell that when you throw in your graph calculator, or you'd be able to tell it when you do it by hand. Okay? And just a quick, easy way to tell, notice that the biggest this will ever get is 3. So that's how we also know that this has got to be that one, because the biggest sine gets is 1, and so the biggest this will get is 3. Same thing here, the biggest this will ever get is 2, so there's, you see a radius of 2 right there. So, you know, there's even if you throw in your graphing calculator and forget which one is which, it's fairly easy to figure out which one it is. Okay, so basically we want to know, we want to be able to graph this, or to integrate this thing. So notice from these two lines that I had to draw on there to begin with, if I integrate from this line to that line on just the heart-shaped thing, that'll take care of most of my area. But hopefully you notice there's this little section down here that's not covered by that. So these little guys right here would not be included. So if I just integrated, so in other words, if I just set up and integrated from A to B, where this angle right here is A, and that angle right there is B, oops, sorry, B, and I'd just be using this one, so that would be 1/2 1 plus sine theta squared d theta. Because again, I'm using that area of the sector formula. If I just did that, I would find most of the area, but we're missing these little slices. So we have to do something else to get that. Now, I also wouldn't just do this. I would probably just integrate from here to there, and then double it. It doesn't really matter, but we do notice that those are symmetrical. So you could do it this way, or you could just do from there to there and double it. Okay, so let's set that up. So the first thing we need to know is what A and B are. And that's what I did over here. We know that the two functions have the same r at these 2 points. So what I did is I just set them equal to each other. Sine of theta, or 3 sine theta is equal to 1 plus sine theta. And if I subtract sine theta from both sides, I get 2 sine theta equals 1. And then if I divide by 2, I get sine of theta is equal to 1/2. So then we got to finish this. So when is sine equal to 1/2? Well, we know that sine is equal to 1/2 when theta is pi over 3 or 2 pi over 3. If you think about the unit circle, right there and right there, because, whoops, no, that's not true. I lied to you. Good thing I drew this unit circle. If you think about the unit circle, we want the vertical to be 1/2. So it'd be like this guy and that guy. Yeah, so that'd be pi over 6 and 5 pi over 6. So that's when these two functions are equal to each other. So that means that a is pi over 6. So what I want to do here is I'm going to integrate from pi over 6 to right here, and we can tell that that right there is pi over 2. And I'm going to double it because I know that these two pieces are the same. So I multiply 2 times 1/2 and I get just that. So that's going to take care of the big part of the region. Now to get these little slices, first thing I notice is that if I let me try to build this up a little bit. And so if I start drawing some sectors, they're going to look like this. So notice that the sectors are being determined by this line here, which is the 3 sine theta. So this one is going to be, it's going to have 3 sine theta. 3 sine theta as my radius, d theta. But notice there's 2 of them, so if I just integrate from here to there, that would take care of half of it, so I'm going to double it. So again, I don't need the 1/2 out front. So now the question is, what are the thetas that give me this? Now I know that this thing ends right there, which we said is pi over 6, so I'm going to do it pi over 6 there. So then, so where do I start? Well, my guess is 0. Let's check and make sure that's true. When I plug 0 in here, sine of 0 is 0, and so sure enough, that's the right starting point. So I'm going to put a 0 down there. So let's make sure we're clear on this. This right here is going to calculate, if I put a 1/2 out front, that would calculate this region, and I double it, so the 1/2 disappears to get the whole region here. And same thing here, if I put a 1/2 out front, that'll take care of this little slice here. If I double it, that'll take care of this slice and that slice. So together, these should give me the total area of that region. Okay, so to make sure this doesn't go too long, I'm going to end the video here. You can, if you're good at if you remember integration, you should be able to handle this. And also keep in mind that reducing power identity that I showed you up here. So the same, it's similar for sine, I guess. It is a little bit different. For sine, it would be sine squared theta or sine squared u is equal to 1 minus cosine 2u over 2. So it's the same thing, only minus instead of plus. Okay, so you can go ahead and do that on your own. And I would also, just for your exercises, just for your help, or just for your practice, here's some more examples that have the solutions written out for you. So I would advise that you try some of these. You know, look at the equation, look at the pictures, and see if you can come up with a plan. Try it on paper, then come back and look at what the answer that I have here. So there's a couple of examples like that you can try practice on. And I tried to explain this so that it makes sense. But anyway, give it a shot and let me know what questions you have. All right.